Hello my dear students, welcome to Easy Technical Academy. Myself Bhavesh Devra, and today we'll study mechanical vibration. So we have to start with basics. So what is vibration? If there is a to and fro motion from the equilibrium position, this is the equilibrium position, and if there is a to and fro motion, then we can say that it is vibration. हम इसे क्या कहेंगे? Vibration कहेंगे. तो there will be a mean position और इस पोजीशन जब टू एंड फ्रो मोशन होगा दोनों डायरेक्शन में, दैट इज कॉल्ड वाइब्रेशन. फॉर एग्जांपल, वी हैव simple pendulum. This is the simple pendulum and it will move like this. Again there will be a to and fro motion from the equilibrium position. It is also called vibration. So this is the zero position. Or equilibrium position. Equilibrium position. So it is called vibration. So let's take a simple example or simple vibrating system. That means spring and mass system. We have a spring and we have a mass here. So if there is no mass, the position of spring is this. But if there is a mass, then spring will get stretched and reach to this position, right? So this position. So this will be the deflection in this spring. So the free body diagram of the system is like this: mass, which will act downward, that is mg, and the force act upward direction, which will be the spring force. It will be k into delta, right? So this is the basic of vibration. So from here we can say that number one, to and fro motion called vibration. Number two, simple harmonic motion is vibration. And number three, if there is a oscillations from the mean position, it is known as vibration. So mean position can be called as zero position or equilibrium position. These all are same, right? Same thing. So now let's understand the general system of vibration. General system. So in general system we have a spring, we have damper, and we have mass. So spring has spring constant K. We have damper, which have damper coefficient C. So this is the general mass system and this is the force acting downward direction, right? This is the general mass system. But if we want to work out undamped free vibration, then our system will be like this: simple spring mass system. Since it is undamped free vibration, so we are removing the damper, and if we apply the force, initially we apply the force to the member or to the system and then removed, then that is known as free vibration. But if the force is applied continuously, that will be the forced vibration, that we'll study later. So in free vibration, what we'll have to do, just apply the force and then remove the force. The body will vibrate itself continuously from equilibrium position. Initial excitation is given. तो initially से हम excitation देंगे, right? So this is what undamped free vibration. Now what we have to do, we have to analyze the vibration with the help of method, that is equilibrium method. Equilibrium method. Equilibrium method. So in this method we have again spring mass system, simple spring mass system. ये simple spring mass system है, and initially there is no mass is attached, right? But as the mass is attached to the spring, the spring gets stretched due to the mass m. Mass m की वजह से spring क्या होगी, stretch होगी, and there will be a deflection because of this mass. Since there is deflection, so the mass, because of the mass, the force will act downward. It will be the mg, and there will be resistance force, which will be the spring force, that is k delta, which will act in opposite direction but have equal in magnitude to the downward force. Now, since we are dealing with undamped free vibration, then what we have to do, we have to give the initial excitation to our system. Initial excitation to our system. So we have this position. So we have this position. Now initial excitation is given, and we reach to this position, right? So there will be a deflection, initial deflection, because of mass m is delta, and because of the initial excitation there will be a again deflection x, again it is our m. So if we draw the free body diagram of this system, the spring force will act downward, which is mg, and the opposite force will be k into x plus delta, because deflection will be x plus delta because of the initial excitation. Because of initial force is applied. Initial force is applied. So this is our free body diagram of the system. Now the motion of this body will be downward, and the inertia force will be act in upward direction. This is the inertia force. Inertia force which will reach the body to the equilibrium condition. So inertia force will be mass into acceleration. So this can be written as m into x double dot, right? तो acceleration हम क्या लिख रहे हैं, x double dot लिख रहे हैं, right? So now चलो देख लेते हैं. So if there is a velocity, we can write dx by dt, इसको हम लिखते हैं x dot. If there is an acceleration, we can write dx square by dt square. Sorry. Dt square is equals to x double dot. So from according to D'Alembert's principle, we can say that the summation of inertia force plus all the external force equals to 0. So this is from the D'Alembert's principle. So we can write the equation. So we consider the downward force as negative, that is negative mg, and upward force k delta plus x, and upward direction inertia force will be mx double dot is equals to 0. So from here what we can say like this: m minus mg plus k delta plus kx plus mx double dot is equals to 0. So from this equation, from this condition, we can write that mg is equals to k delta. So from here mg and k delta is cancelled out. So we left with the equation, that is mx double dot plus kx equals to 0. So dividing m on both the sides, we left with x double dot plus k by m into x is equals to 0. So our final equation will be x double dot plus omega n square x is equals to 0. This is our final equation for undamped free vibration system. So from this equation, we can write, comparing these two equations, this and this, we can easily write omega n square is equals to k by m, and this k by m will be can be written as omega n. This equation can be written as omega n, is equals to under root k by m. So this is the frequency of the undamped free vibrating system. Now if you want natural frequency is divided by f. F is equals to what? Omega n upon 2 pi. So our natural frequency can be written as omega n, that is 1 by 2 pi into omega n is what? K by m. Similarly, if you want to write time period, that is Tp, it will be Tp is equals to what? It is the reciprocal of frequency 1 by f. So it will be 2 pi under root m by k. The unit of this frequency is in radian per second, and unit of this frequency is hertz, right? So this is all about mechanical vibration and the method, that is equilibrium method. System is undamped free vibration. Thank you.